Okay, in previous lessons, we learned how to solve right triangles. In this lesson, we're going to learn how to solve an oblique triangle. And all an oblique triangle is a non-right triangle, because obviously not everything in the real world is a right triangle. And we're going to do so by using the law of sines, and then we'll talk about the law of cosines, which is also another method. Here's what the law of sines states. It says the law of sines can be used to find the side and angle measures giving two angles in any side. So you could be an angle side or angle side angle type relationship. And what I mean by that, you could be given maybe this angle and then this side over here. That'd be an angle side. Or you could be given this scenario. That'd be an angle side angle, to where notice the side is between the two. Or it also works for side-side angle relationships, where you have a side, and then the non-included angle, such as this. So you can use it for any of those scenarios, and here is the law of sines. It states that the sine of an angle, sine of A, over A. Now here's the important part. Notice that angle A and side A are always across from each other, is equal to the sine of angle B over side B. And again, notice the same thing about B and B. And that's also going to equal the sine of C over C. And now with the law of sines, you're going to use two of those pieces of information. You might use this is equal to this, or you might say this is equal to this. You're not going to use all three at the same time. So let's work a problem just to show you. Find each missing measure and round your answers to the nearest tenth. Now the setup here is super easy. Here's all you have to do. Find an angle and the side across from it. The sine of that angle over the side across from it will always equal the sine of the other angle over the side across from it. It's a proportion. And if you don't remember how to solve proportions, real quick, if you had like 3 over 4 equals x over 5, shortcut for solving proportions, multiply the two numbers that are diagonal and then divide by the other number. This would be 3 times 5 divided by 4. So to solve this for x, we've got to do simply 15 times the sine of 104, divide that by the sine of 47, and you get about 19.9 centimeters. And that's it. That's your missing side length. Next problem. The sine. Now we got a problem here. This is the angle side angle type relationship. And here's my rule. I don't ever memorize which relationships you use. I just try to use law of sines. And if it doesn't work, then I'll try the law of cosines, which we'll talk about in our next video. But here, if you've got two angles, then honestly, you've got all three of them. To find that third angle, you add these two together, 63 and 42, that's 105. Subtract, this angle is 75. Now let's set it up. The sine of 75 over the side across from it. You have to have an angle and a side across from it, or you cannot use the law of sines. So here we have it. 75 is across from 28. We can use the law of sines. And that's going to equal the sine of 42 is across from x. So we're going to set it up as the sine of 42 over x. And we don't even need the 63 in this one. Solve this proportion by multiplying 28 times the sine of 42. Divide that by the sine of 75, and you get about 19.4 feet. Number 3. You have an angle that's across from a side, so we can use law of sines. The sine of 92 over 11 is equal to the sine 65 is across from x, so the sine of 65 over x. To solve this proportion, multiply 11 times the sine of 65, divide it by the sine of 92, and that's going to give you your x value, and that's going to be approximately 10.0 meters. Number 4. Let's see, we don't have anything across from 14, but we do have the other two, so we can find this third angle. 32 and 35 add up to 67. Subtract that, and you get 113 degrees. So let's set it up. The sine of 113 over the side across from it will equal, now we're looking for x here, so we're going to have to use the 35 because it's across from the x, the sine of 35 over x. We're going to solve it like proportion. 14 times the sine of 35, divide that by the sine of 113, and you get about 8.7 yards. Okay, number 5 says a pilot begins a flight traveling 80 miles northwest. So you have your starting point here, and he travels 80 miles northwest, which you see here. To avoid the storm, he makes a turn. Then he returns to his original location. The diagram of the flight is shown to the left. Find the total distance of the flight. So we've got to have all three side lengths. We have this 80. So let's see if we can use our law of sines. Now we've got to have all three angles, I believe, to be able to work this. So if this is 15 and 108, that's 123. That leaves us with a 57-degree angle here. So now we have the sine of 57 degrees over 80 is equal to, I don't know, let's find this side first. The sine of 15 over x. Again, solve it like a proportion. That's going to be x will equal 80 times the sine of 15. Divide that by the sine of 57, and you get 24.7. Next up, let's find we'll call it a y value. We're going to start it out the same way. The sine of 57 over 80. Scroll over. The sine of 57 degrees over 80 is equal to, now to find y, we're going to have to use this angle instead. The sine of 108 over y. Solve it like a proportion. Y is going to equal 80 times the sine of 108 divided by the sine of 57, and you get 90.7. So if y is equal to, let me label it over here. If y is equal to 90.7, x is equal to 24.7, his total trip would be 80 plus 24.7 plus 90.7, which gives you a round trip of 195.4 miles. Okay, now let's work it backwards. Finding an angle given side-side angle. Now you got to watch out here. When finding angle, it's possible to have one solution, two solutions, or no solutions. And we'll talk about in a second why that is true. The sine function always has a range between -1 and +1. If you ever have sine that is equal to 2.3, there's no solution there. The sine of nothing can be 2.3. And the reason for that, if you remember that sine is actually equal to opposite over hypotenuse, well, hypotenuse is always the longest side of a triangle. You can't have a value over 1. Angles with a positive sine function can lie in quadrants 1 and quadrant 2. So that's going to be a little tricky. That's what's going to present the problem. Because let's say that I tell you that the sine of some angle is equal to 1/2. Now before, what do? We moved the sine over, we took the inverse sine of 1/2, and we got 30 degrees right here. But there's an issue because there's actually another angle that has the exact same reference angle over here, which is 150, that also has a sine of 1/2. Because it has the same reference angle. It's also positive, and remember that's where this came from. Angles in quadrants 1 and 2 can be positive. So when we're solving these problems, we might have two possible answers. Now to find the other possible angle, notice what's true about these. Since they're in quadrant 1 and 2, let's find another one. Like what if this was a 50-degree angle? Then what over here has a reference of 50 degrees? That'd be 130 degrees. Has a 50-degree reference as well. Well, notice about the sum of these two. 150 and 30 adds up to 180. 130 and 50 adds up to 180. A 60 and a 120 have the same reference. They add up to 180. So to find the other possible solution, we can actually just subtract our original solution from 180, and it's going to give us that second quadrant angle. The sum of the two angle measures in a triangle is also always 180. That's going to allow us to check for, well, sometimes these solutions won't work. If we get three or a couple of angles that add up to something bigger than 180, we got a problem there. No triangle can have two obtuse angles. So keep that in mind as well. If you've got an obtuse angle, well, you can't have a second obtuse angle. It's not even a triangle. So all these things we're going to keep in mind as we're working these. and hopefully it'll make a little bit more sense as we're working these out. Information about triangle ABC is given below. Check your answers and give all the possibilities. So they're telling us what to find. So I'm just going to kind of sketch out a triangle here. And it might not look very accurate compared to what the triangle is supposed to look like. Angle A is supposed to be 60 degrees. AB is 30 inches. BC is 27 inches. We're asked to find the measure of angle C. So let's use our law of sines. We have the sine of 60 over 27, started out just like we did last time, is equal to the sine of C over 30. Now, here's the issue. Now we're looking for an angle. So here's how we do it. I like to start out like this. Get rid of division by 30 by coming over here and multiplying by 30. And we're going to type all of this into our calculator. 30 times the sine of 60 over 27. And you get about 0.9623. However, that's not our answer. Because look what that's equal to. It's not equal to C, it's equal to the sine of C. So we've actually got one more step that we've got to go through. We've got to get C by itself by taking the sine like we did in an earlier lesson, and we've got to move it to the other side by doing the inverse sine. Now, something we didn't introduce in that other lesson is, hey, inverse sine of 0.9623 might have two answers. It might have a first quadrant answer and a second quadrant answer. Your calculator only gives you the first quadrant answer. When you type this in, you get C is equal to 74.2 degrees. But there's an issue because there's another angle. Okay, let's sketch at 74.2. There's going to be another angle in this second quadrant that has the same reference angle of 74.2. Now, how do we find that? Well, if this is 74.2 and I need to find this angle, you can subtract it from 180. And that's what they're saying up here. To find the other possible angle, simply subtract from 180. So 74.2 is one of your angles, then 105.8 will be the other possible angle. Now the last one says, now wait a minute, the sum of the angle measures in a triangle has to be 180. So let's go back to this. Is this possible? Could this angle C be 74.2? Because this one's 60, this one's 74.2, yeah, that's fine. However, could this angle measure be, let me erase it, could it be 105.8? I don't know. Add these two together and you get 165.8. Does that leave any space for this one? Sure, that's fine. There's actually two possible triangles that satisfy this condition. Number 7, let's do it again. Let's sketch a triangle. You have triangle ABC again, A, B, and C. Says the measure of angle C is 89 degrees. AC is 34. AB is 26. We're asked to find the measure of angle B. So therefore, here's how we're going to do it. We're going to do it the sine of 89 over 26 is equal to, we're looking for angle B, so that'd be the sine of B over 34. We're going to take that 34, mark it out, move it over here by multiplying. So we're going to type all that into our calculator. Now, did we use did we solve it like proportion? Yeah, we did this times sine of 89 divided by the 26. However, when you type that in, that doesn't give you your final answer. It gives you the sine of B. So type that in, and here's what you get. 1.3075 is equal to the sine of B. You can move the sine over by doing the inverse sine, but if you read read our topics at the top, something's an issue here. The sine function always has a range between -1 and +1. Can some angle have a sine of 1.3? As you type this in, you see that it returns an error. There's no solution here. Now, why is that? Here's why. If you were to take an 89-degree angle, notice it's across from 26. In order for B to be across from 34, it would have to be bigger than an 89-degree angle. Why? Because this opening creates a 26 length side. This opening, in order to create a bigger side, would have to be a bigger opening. So it might have to be like 95 or 96 degrees. Well, there's an issue there. If this has to be like 96, let's say, Well, 96 and 89 is already way bigger than 180. You can't have two angles in a triangle that add up to over 180 because the three angles have to add up to 180. All right, let's try another one. Number 8, let's draw triangle ABC. A, B, and C. C is a 102-degree angle. AB is 24 yards, and AC is 21 yards. And again, that's that side-side angle scenario. So we have the sine of 102 over 24 is equal to the sine, we're looking for angle B, the sine of B over 21. Again, we mark out the 21 and move it over by multiplying. Type this into our calculator, and that tells us that the sine of B, let me try that again, is equal to 0.8559. So therefore, B is going to equal the inverse sine of that 0.8559. When you type it in, you get B is equal to 58.9 degrees. But again, there might be two answers. Remember that sine is positive in the first and second quadrant, and I told you to find that second quadrant angle, all you have to do is subtract this from 180. You might see a problem already coming. When you subtract this from 180, it gives you 121.1 degrees. However, look, 102 degrees. The three angles in a triangle, this one's fine. The three angles in a triangle have to be smaller or has to equal 180. So therefore, this one and this one can't be bigger than 180. You can only have one obtuse angle in a triangle. So honestly, you can go ahead and throw that other obtuse angle out. It can't be a possibility. Number 9. Again, let's draw triangle ABC. Let's label angle B is 95 degrees. AC is 34 and BC is 21. So law of sine says that you have the sine of 95 over the side across from it is equal to, we're looking for the A value here, the sine of angle A over the side across from it. Mark out the 21, multiply it, and that leaves you with the sine of A is equal to, when you do all this work, you get 0.6153. To find angle A, you move the sine over by doing the inverse sine of 0.6153, and you get that A has a value of right at 38 degrees. To find the second possibility, you subtract that from 180, so you have a second possibility of 142. To check to see if those possibilities work, okay, angle A here, could it be 38? That's going to be fine, but there's a problem. When you take the 142 and you add it to the 95, which is the only other angle you already get something bigger than 180 degrees. Since it's bigger than 180, the three angles have to add up to 180, so you can throw out the 142 because we know it won't work. Number 10, draw your triangle. A, B, and C, let's label. C is going to be a 30-degree angle. AC is 29, and AB is 28. So we have the sine of 30 over 28 is equal to, we're looking for B here, the sine of B over 29. Now this one you could actually solve without a calculator because the sine of 30 is one of your common angles. That's 1/2. However, to do this, we're going to mark out the 29. We're going to multiply by it, and that gives us the sine of B is equal to, again, it'll be 29 times 1/2 divided by 28. That's going to give you a value of 0.5179. So to find angle B, we're going to move our sine over by doing the inverse sine of 0.5179. And again, remember that this could have a possibility of two different answers. Type in the inverse sine of 0.5179 and you get 31.2 degrees, or the second answer would be 148.8 degrees. That's right. Let's see if both of them are possibilities. So could be 31.2. Add this to it to see if you're less than 180. This is fine. When you add 148.8 to 30, you get 178.8, which is less than 180, so they're actually both fine. Now that's going to be borderline. That just leaves you a little bit. If this was actually 148.8, that only leaves you with, let's say, 178.8. This would have to be a 1.2 degree angle. That would be a very tiny angle, but it is possible. Okay, the last one. Let's draw our triangle. Label your angles A, B, and C. We're given that angle B is 125 degrees. We're given BC is 24, and we're given that AC is 21. So our law of sine states that sine of 125 over 21 will equal, we're looking for angle C here, the sine of C over. Notice that we're not given the side length. So we have an issue here. So here's what we're going to have to do. We're actually going to have to find A, because we are given the side length across from it, which is 24. Now, if I can find angle A, then that leads me to knowing what angle C is going to be equal to. So let me show you how we're going to do it. So let's go ahead and find angle A. Let's solve this by moving the 24 over. So we're going to do 24 times the sine of 125. So that gives me the sine of A is equal to 0.9362. Move the sine over by doing the inverse sine, and I get A has a value of 69.4 degrees. Or to find that second value, subtract that from 180, and I get 110.6 degrees. Okay, so let's check these. So if A is equal to 69.4, and again, we need to find angle C. What you would do is take angle A, add it to angle B, subtract from 180, and that gives you angle C, but I have an issue. If you add 69.4 and 125, you get something larger than 180 already. So it's impossible for A to be 69.4. So move on to the other one, and that one's definitely not possible because those two are obtuse. But again, if you had worked it out and it had been something that you could have found, let's say that this is a 30-degree angle or a 150. What you would have done, 30 degrees plus the 125 subtracted from 180 would have gave you this first answer. 150 plus 125 would have been too big, so you'd have thrown that one out. But that's how you'd have worked it to have found that angle C if it was workable.